Hello everyone, my name is Rugul, and today my partner and I myself, my partner Omkar Sadhi, will be presenting the topic color image segmentation using region growing and region merging, which we have implemented. So first comes the question: what is image segmentation? Image segmentation is the process of dividing an image into multiple regions or segments. It is an important task in computer vision with various applications such as object recognition, image editing, and medical imaging. Image segmentation is a challenging problem due to factors such as noise, occlusions, and variations in lighting and texture. Now, what is region growing algorithm? Region growing algorithm is a simple and intuitive approach to image segmentation. It works by iteratively grouping neighboring pixels that satisfy a certain criteria. The criteria can be based on color, texture, or intensity similarity. Once a region is formed, the algorithm can be repeated to grow other regions. Now, what are the steps of the region growing algorithm? First, initialization. First, we select a seed pixel and initialize a region with it. Second step, selection. We identify neighboring pixels that satisfy the similarity criteria. Third, neighbor merging. We add the neighboring pixels to the region and update the region properties. Fourth, iteration. We repeat the neighbor selection and merging until the region stops growing. Fifth, stop criteria. Define a stopping and condition such as a maximum region size or a similarity threshold. Now, as we have listened to the steps of how to perform region growing algorithm, we have come come to know advantages and disadvantages. First are the advantages. It is easy to implement and computationally efficient. Second, can handle non-uniform regions and noise. Third, can be combined with other segmentation algorithms. Disadvantages: sensitive to the choice of seed pixels and similarity criteria. Second, can be sensitive to variations in lighting and texture. Third, may result in over-segmentation or under-segmentation. Now I will pass on the mic to my friend Omkar Sadhu.
Now let's see what is region merging algorithm and its steps. Region merging is a complementary approach to region growing. It works by iteratively merging neighboring regions that satisfy a certain criteria. The criteria can be based on region size, shape, or similarity. Once a region is merged, the algorithm can be repeated to merge other regions. Now let's see the steps of region merging algorithm. First is initialization. Initialize a set of regions, each consisting of a single pixel. Second, neighboring selection. Identify neighboring regions that satisfy the merging criteria. Third, neighbor merging. Merge the neighboring regions and update the region properties. Fourth, iteration. Repeat the neighbor selection and merging until no more merging is possible. Stop criteria is the last step. Define a stop condition such as a minimum region size or a maximum number of regions. Now let's talk about the advantages and disadvantages of region merging. Advantages: it can handle over segmentation and under segmentation. It can also be combined with other segmentation algorithms and can be used for hierarchical segmentation. Disadvantages includes sensitive to the choice of merging criteria and stopping condition. Can be computationally expensive and may also result in merging of dissimilar regions. Now, as we have seen region growing and merging, let's talk about our main topic, which is color image segmentation using region growing and region merging. Color image segmentation using region growing and merging is a popular approach in digital signal and image processing. The goal of image segmentation is to partition an image into different regions or segments based on some criteria, such as color, texture, or shape. Region growing and region merging are two common techniques used for image segmentation. The combination of region growing and region merging can provide more robust and accurate segmentation results than using either technique alone. In this approach, the image is first segmented using region growing to obtain initial regions, and then neighboring regions are merged using region merging to refine the segmentation. This approach can effectively capture both local and global properties of the image and produce segmentation results that are consistent with human perception. Overall, color image segmentation using region growing and merging is a powerful technique for extracting meaningful information from images, and it has numerous applications in areas such as object recognition, image retrieval, and image and medical imaging. Here are the general steps for performing color image segmentation using region growing and merging. First, input image. Load the color image that needs to be segmented. Second step is pre-processing. Perform any necessary pre-processing steps such as noise reduction, color space conversion, or histogram equalization. Then we have to perform region growing. Select a seed pixel or a group of seed pixels from the image. Define a similarity criteria such as similar similarity, texture similarity, or a combination of both. Starting from the seed pixel, iteratively and neighboring pixels to the region if they meet the similarity criteria. Now continue the process until no more pixels can be added to the region. Next, we have to perform region merging, in which use the segmented regions from the region growing step as an initial segmentation, then define a merging criteria such as a similarity threshold or a minimum size constraint. Iterate through all neighboring regions and merge them if they meet the merging criteria. Lastly, continue the process until no more regions can be merged. Now, post-processing. Perform any necessary post-processing steps, such as removing small regions or filling gaps between regions. Output segmented image. Finally, the output of the segmented image where each pixel belongs to one of the segmented regions. Now let's see the implementation of the code. Here is the implementation of the code, and here is the resulting output. Thank you.